So it will have to be in English, sorry. My Czech is nowhere near good enough to do this in Czech. Anyway, how many of you guys know what OpenStack is? Because most of you guys are Python programmers, so...
Sort of.
So you've heard of it and have an idea of what it is. Okay, so I will try to... this is kind of like what my slides will be about. Slides are mostly marketing type slides, and this is because we have people who do slides for us at our company, so I don't have to actually spend time doing slides, but I will talk about technical things in between the marketing bullshit. So, I'll give you an overview of what OpenStack is and what infrastructure as a service is, and you guys probably know what it is, but I will try to like put like what I wish somebody told me when I was like a programmer not doing this before. So that's one thing. Then I will tell you what we do with OpenStack at Red Hat, because that's interesting and we're supposed to hire some of you people at one point, maybe. So that's why we're here. That's 70% not the joke. And then I'll tell you about our product, and if you want to try out OpenStack, it could be useful for developers. I'll tell you how later. So that's what 3 and 4 is about. I'll keep it short, that's why it's only 20 minutes. So without further ado, overview. This is obviously a marketing slide. Like no developer would ever put this on a slide. But it's actually on the OpenStack website. And the idea is it's infrastructure as a service. Now this means that you have like hardware, and then you can virtualize virtual machines on top of that hardware, and then you can like run operating systems on top of those virtual machines or inside those virtual machines, and then you can like actually deploy applications inside those virtual machines. And the infrastructure as a service is kind of like you virtualize your hardware, so they have the illusion of running their own machines, but it's actually virtual machines that you're. So what it is, and what like there's probably next slide is like these are the benefits that influence what it is. It's like pushing one set of problems that people used to deal with by hand, pushing it to software. And this is actually what a lot of software industry is about. This like taking problems that people used to do by hand and like solving them with software. And apparently people had a lot of trouble dealing with this by hand or with you know. So it actually turns out to be pretty useful. Now what these slides don't have is like, you could virtualize your data center. You could put your you could buy like out-of-the-box servers, and you could provide the illusion that you're running whatever, Windows or CentOS or Ubuntu or whatever on top of that. That's fine, but what's really more interesting and is not part of the slides is virtualizing your network. Because network used to be like a monopoly of a couple of companies that used to have like closed, non-interworkable parts. Well, they were kind of interworkable because it's a network, but not really, and you couldn't manage it, and you had to employ like a lot of people actually provisioning services on your network like by hand, and this was their job. And this was happening like up until like 2 years ago, and virtualizing networks is something that's a real revolution. So if you like take anything from what I'm talking about, it's like that, okay, virtual machines are cool, you have containers now, Docker, everybody heard about that, but actually virtualizing networks is a really, really cool technological advancement. So marketing people would tell you that these are the benefits of running infrastructure as a service, but we are people who write software, so we know that pushing problems, solving them by software is why we get all the big money that we get. So, right? So this is what OpenStack is actually all about. It's an open solution for handling all the virtualization in a data center. And it's open source. Now, this is important. You all guys write in open source languages, you probably have an idea why being open source is important, and especially if you're part of the Python community, you know why being community driven is important and cool. So, yeah, and this is like one of our like technical leads, and this is one of his tweets, and this might be obvious to people doing web, but it's not obvious to people who come from more enterprisey background, and this is a really big thing. This is why open source is cool in big companies. Okay, so a bit more on the technical side. So the idea of OpenStack is that it provides you with the cloud. Now that, you know, is a buzzword in itself, but there are some actual things that are happening there. So you have compute, which is kind of like how you handle your virtual machines. So it's like basically a piece of software that will allow you to track what's happening with your virtual machines. It will give you like users, it will give you who's doing what, quotas, all the things you could imagine. Like this is actually my favorite. One of my favorite interview questions is like, how would you actually design a database to support this? And like, so if you can imagine what you would do to track all the virtual machines in your cloud and in your virtualized data center, that's like what the compute part of it does. Then you have the image service, which provides images for virtual machines because you want to actually have some code running at one point. So images are very handy for that. We won't go into detail about this. So Swift is best described, and I hate to describe things in Amazon terms, but I think Swift is best described as S3 done by open source people. So it's like an object store you can access through HTTP, you can like store your stuff files there, you can actually serve files off. It will be replicated amongst many servers using advanced technologies such as rsync, and it actually works. So Quantum, actually we had to, this slide is old because due to copyright we had to rename it to Neutron. But it's the thing that lets you virtualize networks. And this is like, I won't be talking about this a lot, but it's really interesting. So if you want to go and check out something after this talk, go and check out Quantum and Neutron and how it works. And Cinder is basically virtualizing your storage, so you have huge amounts of storage that, and you have like iSCSI, and you can set them up, hook them up to your virtual machines. And there's like identity management at one point, because this problem was apparently never solved before, right, Peter? So we had to resolve it again. Anyway, and the idea of OpenStack is to do this in Python, which is a modern language that's apparently really easy and quick to develop in, and to be really, really scalable. So scale out to from like, well, some of the users of OpenStack at the moment are Rackspace and eBay, and they all are, you know, pretty high scale.
Where are we?
3 minutes.
3 minutes
left.
more? Oh, sorry about that.
Cool.
Go on.
Okay, so this is a bit more functional diagram. So like you can, if you were following, you can imagine how like different components work together. And let me try to like walk you through a life cycle of a person wanting to run a server on OpenStack. And you would ask for a server from a compute service. It would contact the network service to give you like all the network setup. Then it would probably download, actually it would first download an image from the image service, and then it would like hook it up to a network, add some disks to it, and all of this has to go through identity. So you have to be logged onto the system to be able to do this. And there are some design goals. This was I copied this off of the actual website of the open source project. And why this is interesting is because all of these things will lead me to talk about how OpenStack is designed from the software perspective. So how the classes are laid out, and this is coming like next. So obviously component-based would mean that you can add stuff. Highly available means many things, but probably it means like if you get front page of Hacker News, your app doesn't die. Fault tolerant means like if something gets messed up, like not everything goes down, but you can like figure out what went, like you can isolate the thing and you can like recover without serious engineering effort.
You can switch your tape now. There you go, thank you.
No problem.
On again?
You are on.
No, I'm recording.
Awesome. That was about 11 minutes.
Okay,
There we
so
go.
this is kind of like the previous diagram, but with like what's happening inside and what's actually happening. It's completely like there's no point in describing this. But what I wanted to show with this slide is that it's a bunch of services, meaning a bunch of daemons, talking to each other through some kind of protocol, whether it's HTTP or like AMQP, and I'm choosing these two because that's exactly what we use in OpenStack. But so what might be interesting to like Python programmers coming from the web side of things, and this is what I got from speaking a little bit of Czech when you guys were coming, what you do is that like instead of having your like kind of like web app that does things and then you maybe like defer tasks to like a message queue and it gets picked up by a worker, actually the whole architecture of all the applications in OpenStack is like you have message queues and there's like tasks being put on message queues, and then there's some other service that might be scaled out to bajillion nodes, or maybe you have just one, and it picks up the task and does this and then presents it back to the user. And it's like, I think it's interesting right now because a lot of the software being written right now is written in this fashion. So I mean, like programmers would be interested in this, I guess. So this is kind of like an example. We're good. An example of how services talk to each other inside of one of the OpenStack projects, and as you can see, there's like stuff being like you need to hook up volumes, you need to authenticate to get the VNC console, you have to like, there's a database somewhere there because there's always a database somewhere, and this is kind of like the software we write and how it's grouped, and I mean, like I thought that people who come from the web background would maybe be interested in this kind of like layout and maybe ask questions later. Anyway, so now plugging my company. Okay, so first, before all of this, I don't know, so you guys are not maybe deeply familiar with OpenStack, but it's like, I saw Joe Gordon, one of the core guys, gave a talk at the last EuroPython about this, the size of OpenStack as a project and what we need to do to keep it going. And we're talking about probably at this moment about 1 million lines of Python code. So it's probably next to PyPy one of the biggest projects in Python, like ever. And probably at the moment, like this stuff changes a lot, and you can like measure size of open source projects by different criteria. Probably like number of deployments is probably Django. Django is the first in this category. But like when we're talking about the scale and, for example, number of patches, we have in excess of 2,000 patches a month under review. So this is a lot of work done by a lot of developers, and there's a lot of momentum behind the project. And like this, with this in mind, this graph may make some sense because we as a company put a lot of effort behind this, and all of this is done mostly upstream. I mean, I don't know if this is not obvious to some people or if it's something, but yeah, we do as a company, we do most of the stuff upstream, meaning with the actual open source community. So I don't know, I had to like show some people that I work with because they're just really good looking. But they are, Mark is actually good looking. But they are,
What is PTL?
PTL means Project Technical Lead.
Oh, I see.
So it means like the alpha and omega of one, because like I said, OpenStack is divided in projects, so we have 3 of those out of at this moment probably 10, because what I showed you were only core projects. There are some other, like for example, I think it's called Amazon RDS, like Relational Database Service. This didn't exist in OpenStack 6 months ago. Now it exists. It's called Trove, and it's a really interesting project because it uses containers rather than virtual machines, because you actually have to be sure that once you flush to the disk, it's flushed to the disk rather than, you know, deal with all the virtualization. So there's a lot of really cool technology happening around OpenStack. That's what I'm trying to tell you. And this is like, again, a marketing slide, why it's important to be involved with upstream. And I don't know if you come from companies that use open source projects, but if you do, I think that being involved upstream is definitely something that developers want and that marketing and managers should want, even though they don't know that they want it. But I think it's important. And now I'm going to, like, I have 4.5 more minutes to plug. RDO is one of the things we do at Red Hat, and that's we take the upstream code and we create our own distribution of the project, and we do a lot of things around making it more easy to set up and work with. And so this kind of like trying to explain to people that upstream OpenStack project is just code, but we put it in packages and whatever, and we use Puppet, so Ruby people should be happy with this. And yeah, and this is like, RDO is our website, so if you want to try like a community-backed open source distribution, go there, download it. It's really easy to set up on Red Hat Enterprise Linux and similar distributions of Linux, so Fedora, CentOS, and similar. And that's it. Now the most important slide is this. We're hiring, and if you have any questions, we have like 3.5 more minutes, so if somebody has any questions, sadly in English, I would be happy to try and answer them.
Thank you.
Thank you.
Thank you. So Q&A.
Working on OpenStack, we can hire you remotely. You do not have to relocate to Brno.
Actual question.
Just put that out there.
I haven't started using OpenShift by Red Hat.
Okay.
What is the, I don't know, what is the difference? What is OpenShift and what is OpenStack? Is there any relation between them?
So there is, and so there's no real relation, but you could be around. So OpenShift is platform as a service. So basically it will provide you an abstraction of running your application server, and you like provision application servers. Now, OpenShift actually needs to run on top of some actual hardware or virtualized hardware, and what we do and what's our kind of like story is we run OpenShift on top of OpenStack, and because OpenShift, like if you need to scale out your app, it would add additional workers, and OpenStack is really good for that because you can provision virtual machines on like, you know, on an API call, so that's how they work together.
What's the target business size for using OpenStack? Because you know, I have my own virtual server for 300 crowns a month, and would it even be beneficial for me to use OpenStack instead of that?
Can you just kind of repeat the question so it's...
Okay, so the question was like, what would be the, so who, basically the question was like, why would you ever want to use OpenStack as a developer? Because you can get the virtual server for 300 crowns a month, and yeah, you could use Amazon as well, or Rackspace, something, but... so the idea is that probably as a developer you don't want to use OpenStack. What you might want to use OpenStack is if you work at the company that probably deploys on Amazon, right? And you might be also running all of your staging on Amazon. And that's costing as much, if not more money than actually your like production server. So if you're like, a bunch of you guys said, I have no idea about Seznam, I know what it is, but I'm imagining like, it doesn't take more than like 3 actual instances load balanced to run Seznam, seeing that it's like a Czech website. Am I wrong?
Yeah.
Tell me more.
Well, Seznam is the biggest Czech company. Is the #1 with the site in Czech Republic. So
okay, so
they have, I don't know, a few hundreds of servers physically.
Okay. So
yeah, two data centers.
Okay, so I had no idea what I was talking about, but that's not the point. So
yeah, I know what you mean. Yeah.
All of these things need staging, need like, you know, and all of these things are cheaper if done in-house than, and especially if you as Seznam run physical servers, so you probably lease it from somewhere. Virtualizing those physical servers would make, I guess, maybe sense. I have no idea. But I actually have no idea what Seznam does except from Seznam.cz.
They have their own servers.
You probably have a lot of more services than the actual website, so yeah, I feel stupid for saying that.
It's recorded, no problem.
Yeah. I'm famous for saying these things in public. I'm used to that, it's fine. But yeah, that would be what, and what people like, some of our developers, what they do is they use it, for example, as a backend to, actually one of our guys, he developed kind of like a plugin, I don't know what's it called, but I think provider for Vagrant. Lots of developers like to use Vagrant. And for example, basically it's a virtualization environment that takes care of all the networking and stuff, so if that's something you think is interesting for you, you could use it. I know that one of our business pitches is like, how much money are you paying to Amazon for your internal VM uses, and like you don't have to pay this money, basically. Again, I apologize for the Seznam putting my foot in the
We're glad to start. Any more?
Yes, please.
Forgive me my stupidity, but I'm really not able to imagine how the virtual network looks like. How would you virtualize network?
Okay, yeah, that's actually a really good question. So the idea is that like you could actually emulate in, or do in software what needed to be done in hardware right now. So all the switching can be done reasonably performantly in software now. So there are software components that can be programmed to do all the networking stuff and without letting the other parts of your cluster know that it's being virtualized. And what's also happening is there's a big push on like hardware vendors like Cisco, who used to be really proprietary, to open up their devices with programmable APIs. So what you will end up with is like a physical network that's programmable. Now there are of course like stuff that are happening there that you need, like what I would suggest, like if you run Linux, look at OpenVSwitch, which is one of the, it's basically like a programmable switch that runs inside the kernel. Yeah, this kind of things are leading up to network being hackable and not locked down by vendors. Did this like make it slightly more clear to you?
Yeah.
Okay.
And this kind of networking virtualization is done all in Python. So you're just taking the raw packets and disassembling them and just managing the switching.
No. OpenVSwitch is written in C, I would imagine. I've never looked at source code, but since everything else in the kernel...
So it's just several other open source components working together.
So exactly. That's exactly how it works. So there's technology inside the Linux kernel that allows you to do this. That is apparently really useful. We provide Python layer for managing this, and then we hope that hardware providers will provide open APIs that talk to each other. There are like OpenFlow is one standard for, I don't know if you've heard about this, but it's like anyway, the idea is that if you want to only talk to virtual machines, which means like virtual machines running inside servers, you're fine with stuff running OpenVSwitch. But if you actually want to virtualize your network and be transparent as to whether your servers are virtual machines or actual bare metal nodes, if you need to have them, then having like this kind of interoperability between hardware vendors like Cisco or Juniper and the open source stuff that's happening in the Linux kernel. Or there are other things. It's not. There are other proprietary things. VMware has a lot of cool technology around there as well. But yeah, so why I pointed at networks out is because like for the last probably 20 years it was completely like you need to learn Cisco and you only know Cisco, and then like if you need to introduce like other hardware into your network, you need to like get consultants, and it's like difficult, and right now it might be changing really quickly.
Thanks.
Okay, cool. Guys, thank you very much. Give a warm applause to Nikola. Thanks again. Tak jo.